for now, why don't we go ahead and head out to the Marshall Space Flight Center in Huntsville, Alabama, where Lori Meggs is standing by live at the Payload Operations Integration Center. Hey, Lori, we're talking a little bit about material science this week.
That's right, we sure are. We're talking about a lot of material science. A lot of materials have been tested on the International Space Station so far, anything from metals to ceramics to plastics, and a couple of workhorses that are managed here at the Marshall Space Flight Center here in the Payload Operations Integration Center have helped process those samples. They're the Microgravity Science Glove Box and the Material Science Research Rack. And joining me now is one of their operation controllers, John Kramer. Thanks for joining us today. John, tell us what your team does here for those two facilities.
We operate the Microgravity Science Glove Box, which provides a controlled environment for the crew to be able to perform experiments.
And how do you help the crew process materials?
Well, the crew is very involved in this with the crew activities, and they follow a set of procedures and written procedures, and we're there to help them if they have any questions.
And you're kind of under the gun right now, I guess you could say. We had some samples come up on the Dragon, and those samples have to be processed and then returned on the Dragon. So tell us about that right now, what you're working on.
Well, right now we're working on CSLM. CSLM stands for coarsening in solid liquid mixtures, and they are life limited, so they have to go up and come down as quickly as possible. And
what are the samples?
The samples right now, there are a lead tin mixture. They're heated to specific temperatures, and then they solidify and they come back down on the ground and they're looked at.
So how long does it take to process a sample?
It depends on the parameters that they have chosen. I believe we have 6 samples. We've gone through 3 sample runs so far. They anywhere from a few hours to a few days.
And a couple of more weeks of this, and then it just keeps on going, right?
And it keeps on going, yes it does.
What else are we looking forward to?
We're after CSLM, I believe we're doing a payload called BASS, and then from there it's payload CCF, SOTI, and InSpace.
And you're supposed to be on console, so I'll let you get back to it.
Thank you.
Thanks so much for joining us, John. I also had the opportunity to speak with Sean Reagan, and he is the manager of the Materials Science Research Rack here at the Marshall Space Flight Center, and he's going to tell us what the Materials Science Research Rack is used for.
Materials Science Research Rack is for processing different types of materials on orbit. Basically, we're taking materials, melting them, having them re-solidify in the microgravity environment of space, so that way you remove the effects of gravity. The PI, the principal investigators, will take those and compare that to what actually happens on the ground, and there's a lot of things they can discover when they remove those gravity effects from that. So this rack provides us the opportunity to go do that with different types of samples.
So Sean, what kinds of samples have we seen in the materials rack?
We've seen mostly metal samples processed so far. The principal investigators will determine what type of samples they would like to process. That will go through a science community review to make sure that everybody agrees, yes, that's a good thing for us to go process on orbit, because it does take a lot to get samples up to the space station to process. So that's been the main thing that we've been going through so far, is the metals. But we can process different types of samples as well.
So it really is an international partnership.
Yes, it is. The European Space Agency, ESA, has been involved heavily with us on this. In fact, they built what we call the right side of the rack. They built the furnace and the processing samples that go on that side. NASA built the left side of the rack to provide power, data, thermal conditioning. And then so far, ESA has been building the sample cartridge assemblies that are processed within the rack.
But we're also starting to build our own for NASA, right?
Yes, we've started a project here at Marshall Space Flight Center to build sample cartridge assemblies for NASA, so we have more U.S. principal investigator involvement in the rack as well.
Let's talk a little bit about the upgrades. You've upgraded some software on the rack, right?
We have. We just finished an upgrade to the software. It was uploaded to the rack back in December. Basically, this software upgrade will give us the room that if we have a communication problem between the rack and the rest of the space station while we're processing at high temperatures, we won't have to do what we call a hard shutdown, basically where we remove all power and services from the rack at those high temperatures. It puts us into a controlled cool down mode, which is better for the rack and for the sample being processed as well. It prevents us from having other issues with the rack.
What temperatures are we talking about?
We're processing generally in the 1,000 degrees C range. The rack can go up to 1,200 degrees C on up to 1,400 degrees C, but so far we've not had any samples processed at those temperatures.
It works just fine at the lower temperatures, if you call that low, right?
If you call that low, yes.
What are the benefits that we learn back on Earth from from the MSRR samples?
When you remove the gravity effects here on Earth and process in the microgravity environment of space, it lets the principal investigators see a lot better about how the materials come together and form different types of materials and different type of bonds between the materials. That can be applied to lots of manufacturing items back on Earth, whether it be turbine blades, or, high-speed turbine blades, or other items all across the spectrum. It has a wide-ranging impact back here on Earth.
Thanks to Sean for that. And that'll do it for us from here at the Payload Operations Integration Center. Now back to you at Mission Control in Houston.